Okay, we'll begin. Happy Friday. It's week 9, so just our very I guess next week's our very last week. Let me talk about PCA. So PCA stands for Principal Components Analysis. This is another example of unsupervised learning. And what Principal Components Analysis will do is it will transform your data and reduce the number of dimensions that you have. So you can imagine having a data set with lots of variables, and probably several of these variables in there are going to be correlated. And certainly if you have some variables that are highly correlated, that can present issues in analysis. In linear regression, you have like variance inflation factor, VIF, and things like that happen when you have variables that are highly correlated, right? So if you have x1 and x2 and they're highly correlated in one random sample, it might turn out that x1 is significant and x2 is not. And then in another random sample, because they're highly correlated, it might turn out that x2 is significant and x1 is not. And so what PCA seeks to do is it seeks to transform your data into uncorrelated variables, and we often use this in the form for the purpose of dimension reduction. Okay, if we can take advantage of the fact that a lot of the variables are correlated, can we then reduce the number of variables and still kind of capture or convey the overall variation that exists in the data? So an example is you might have a housing data set, and the housing data set might have a whole bunch of these variables, like how much square footage you have, and the total square footage, the number of bedrooms and bathrooms, and how big this and that is. And you might also have like what kind of heating system you have, or how nice the kitchen is, or how nice the floors are, and things like that. You might also have information about the zip code and the local school ratings, maybe local crime ratings, maybe the median price of the surrounding homes and things like that. And you might have, 70 variables or something like that. And when you have a whole bunch of variables, it's often difficult to think about them all at the same time. And certainly it's even harder to visualize. And so I would say that, a lot of these variables, they're going to correlate together, and they can then also just be grouped together. And so one is, your square footage, or one is going to be the size of the house. So square footage, number of bedrooms, number of bathrooms, these generally go up or down together. You have your amenities, the kind of the kitchen quality and the floor quality, all of that. And then another is going to be like how desirable is the neighborhood and things like that, okay? And I would say if you have these three aspects, that's going to account for a lot of what's important to a person shopping around for a house or looking for an apartment or things like that, right? So if you and you can imagine, when you visit a website, like any kind of store website or any kind of thing where you're searching for information, the search results page is kind of designed to just give you the most essential pieces of information. So if you're like doing apartment hunting, usually what you will get is probably like the square footage of your apartment, number of bedrooms or something like that, and then maybe a picture, and then the price. And those are like the most important pieces of information. And basically the square footage, number of bedrooms, that's going to be like the size. The picture's going to be like a proxy for capturing like the quality of the, like how nice it is inside that apartment. Price is kind of your outcome variable. And then as far as neighborhood desirability, that's going to be like, I guess, assumed that the person shopping around is kind of aware for that. Maybe it'll be like the city name in there. Okay, same kind of things like when you go on any kind of shopping website, Amazon, Target, Walmart, or something, and you search for a product. What are the pieces of information that show up on the search page? Because on the search page, you're basically, they want to just give you the essential pieces of information, and if you want more information, you click that product, right? So the things you're going to get will be like a picture of the product, maybe the name, the price of the product, and then probably like the overall star rating of the product or something like that. And basically that is dimension reduction. It's taking, there's lots of information about the product, okay? There's probably information about like how big the package is and how much it weighs and things like that, and what, like the country of origin. And these are things that probably most consumers or a lot of consumers don't really care about. Maybe some do, and so that information is there on the product details. But as far as the search results go, it just limits it to kind of like what it considers the essential things. Okay, and so dimension reduction, the idea of reducing the amount of data you have, is useful. Okay, search, like when you are looking at search results, you don't want all of those product details. Okay, and other things. Dimension reduction is useful when you're doing comparisons, okay? And so, for better or worse, GPA is an example of dimension reduction that is frequently used in a lot of different contexts. So, when you're applying for college or grad school, you report your GPA, and that's supposed to just kind of summarize your entire academic performance and career, all of your, and it doesn't take into account little details and nuances, right? It loses a lot of information, but overall it is still kind of useful because you can, a student with a 3.9 GPA compared to a student with a 2.0 GPA, there's a lot of comparisons that you can make, even though you lose a lot of detail, okay? SAT scores and GRE scores, it kind of takes this very complicated notion of, I don't know exactly what it's measuring, intelligence or potential academic success or things like that, and it tries to boil it down to maybe 2 numbers or 3 numbers. You get like if you take the GRE, you get like a verbal score and a math score and a writing score. I think SAT, I don't know if it still has a writing or no writing component, but it tries to kind of boil it down so you can just do something like that, right? And then you have other things, so like credit scores, supposed to kind of summarize someone's like financial trustworthiness. In sports, you have like in the NFL, a quarterback's performance will just get boiled down to what we call a passer rating, and there's a lot of different aspects, in terms of like how many passes they attempted and stuff like that, but that all just gets boiled down to a single number. Okay, and then certainly there are other things where dimension reduction is like almost required. So like if you think about the Olympics and you have like track and field events, you have like the decathlon and the heptathlon where people compete in multiple things. And if somebody comes in like first place for, hurdles, but then like second or third place for the long jump or things like that, you still have to, at the end, you have to boil it down to a single rating system where you're going to have a gold medal, silver medal, bronze medal, and things like that. So that you have this multidimensional thing, and it has to get reduced down to a single score. And so these are applications of dimension reduction. An analogy I like to use for dimension reduction is the idea of a shadow, okay? So we live in a three-dimensional world. All of the objects that we interact with, even things that we often think of as like two-dimensional, like a piece of paper, there is still some depth, okay? Everything we interact with in real life is three-dimensional. But when it casts a shadow, right, you have the light hits it and it casts a shadow. That shadow is two-dimensional, okay? The shadow it projects on a wall or whatever is going to be two-dimensional. And depending on how that shadow is projected, the shadow itself might resemble the object or it might not. There's almost like this form of art where people take objects, and when you look at it, when you're looking at it in 3D, it just looks like a jumbled mess. But then when you turn on the light and it casts a shadow, the shadow it produces looks totally different, right? And it looks, you see the form of, an animal or a person's face. And it's very impressive when something like that happens. That's kind of like the opposite of what we want to do in principal components analysis, where we want the shadow that is cast to look kind of as much like the original three-dimensional object as possible. We want to go from 3D down to 2D and like lose as little information as possible, okay? So when we do dimension reduction, dimension reduction by definition means you are losing information, okay? You are getting rid of some of the variables. But the hope is that even though you are reducing the number of dimensions you have, you are losing a minimal amount of information. Okay, so we want a lower dimensional projection. We basically want a two-dimensional shadow that looks as much like the original data. And so I don't know if I have examples here. I'm just reaching in my bag. But if I just walk over to the projector, okay, and you look at the shadow, like if you see this, you can tell it's a pen, and you have a pretty good idea of like what exactly this pen looks like. You can see there's a cap and there's whatever this flip is, okay? Whereas if the shadow being projected is something like this, okay, then it's hard to tell exactly what this is. If I just hold the pen cap, okay, versus the entire pen, and I just show you this projection here, okay, you can't really tell, am I holding the entire pen or just the pen cap if the projection looks like this, right? So this projection loses a lot of information, whereas this one retains a lot of information. You can tell very clearly if I'm holding the pen cap or the entire pen and things like that, right? Similarly, if I just do this, okay, for the marker, you can't tell. Well, I guess in that case you can't, because the pen cap itself is clear, but there's going to be certain projections where a lot of the information is retained, and other projections where a lot of the information is lost. So we want to, our goal